All right, now back to explaining the stability belt. So if you look at the stability belt, you will see the straight line which shows where the ratio of neutron to proton is 1.1 is to 1. Now below the stability belt, we have more protons. Above the stability belt, we have more neutrons. So which means if I pick any sample here, you will see that that sample has number of neutrons 20. That sample has number of neutrons 20. Now come take it down to this point. Let's say about 35. So number of 35. Now 20 divided will be around 0 point some values. Okay, be having around 0 point some values. Now that 0 point some values is to 1. That is what the ratio will be. So this is your number of neutrons, this is the number of protons. In that At that instance, we have more protons than neutrons. Now if I pick a value from here, if I pick a value from here, let's say here, okay, and then this line is actually 60 number of neutrons, then take it down to around here. That will be around 25. Let's say 25. Let's say this point is 25, so that will be giving us 60 over 25. That will be giving us a value that has a high, will be giving us a value that has 60 over 20. That will be giving us a value that has high number. Okay, so at that instance, whenever a value is above the stability belt, we say that it has more neutrons, and when it is below the stability belt, we say it has. It helps to determine the it helps us to determine whether a nuclei is going to be stable or unstable. Then number two, it helps us to predict the type of radiation that's emitted by an unstable nuclei. So I think in my next video, I'm going to show you how you can actually use it to predict different radiation, whether the radiation is going to be alpha, or whether it's going to be beta, or whether it's going to be positron. Okay, that can be determined band of stability. So our reference point is the straight line. Anyone that is below the reference line has more protons. Anyone above the reference line has more neutrons. Okay, then this green line here shows us number of neutrons actually above 20. Okay, in my next video I'm going to group radioactive elements um, using their number of protons. So I have from 1 to 19, and then the ones that have from 20 to 83, and the ones that have above 83. Then from there we'll be able to use the stability band to actually tell the kind of radiation they are going to emit, depending on if they have more protons or they have more neutrons. Thank you. Please do subscribe to my channel, give me a thumbs up, and then hit the notification button so that we can always notify you when we post videos. Thank you.